A woman wishes to cross a river 60 meters wide in a boat. The river flows with velocity 13 parallel to straight banks, and the boat has a max speed of 5 relative to the water. She heads at an angle alpha to the upstream, and her actual velocity is at an angle theta to the downstream. Show that tan of theta is equal to this guy here. Okay, quick sketch. Parallel banks. She's here. The river flows this way at 13 meters per second. She is going to head upstream at an angle alpha, but her actual velocity is downstream at an angle theta. So we can get her initial velocity of the woman relative to the river. If she can go at 5, she's going in this direction here, negative positive, so she's going minus 5 cos A in the I direction and plus 5 sine A in the I direction. We have the velocity of the river, so we'll be able to get the velocity of the woman or the boat or whatever you want to call it. So the velocity of the river is just 13 in the I direction plus 0 in the J direction. So the velocity of the woman is these two added together. So that's going to be 13 minus 5 cos alpha in the I direction plus 5 sine alpha in the J direction. We're asked to show that the tan of theta, well, the tan of theta, her actual velocity is equal to 5 sine alpha, the J components, over 13 minus 5 cos alpha, the I component, which is what we have here, 5 sine alpha over 13 minus 5 cos alpha. Using calculus or otherwise, prove that tan theta has a maximum. So differentiation, I'll just write dy dx for shorthand, dy dx and let it equal 0 and solve. That's how we show something as a max or a min, and it's when cos A is 5 over 13. Okay, let's just do that first. We have tan theta here. Now, this is a function, it's a quotient rule. If you're doing this early in 5th year, you may not have covered this in calculus, but if we differentiate sine A, we get cos A, so 5 sine A goes to 5 cos A. So you've looked at my differentiation videos, I always say write down the differentiated parts first. 13 minus 5 cos A goes to minus sine A, so minus 5 cos A goes to 5 sine A, minus minus. And the rule for quotient rule, I'm differentiating tan theta with respect to A, the angle, or whatever's in this question here, could be X, this time it's A, the angle A. So quotient rule is on the bottom, we put the bottom squared, 13 minus 5 cos alpha to be squared. Because we're going to let this equal 0, it's always the top that's going to be 0, so you don't have to simplify the bottom out here. Just be careful when you're starting here, it's always the bottom by the top differentiated, 13 minus 5 cos alpha, the bottom by the top differentiated, which is 5 cos alpha, minus the top 5 sine alpha by the bottom differentiated, which is also 5 sine alpha. So we can see 25, an extra bracket in there, I don't. So I have 13 by 5 cos alpha is 65 cos alpha, minus 5 cos alpha by 5 cos alpha, 25 cos squared alpha. I also have 25 sine squared alpha. I can do this, I can write over the bottom squared, just leave it like that. So I have 65 cos alpha minus 25 by cos squared alpha plus sine squared alpha, which you may have seen is equal to 1 regularly, over the bottom squared. So we have 65 cos alpha minus 25 equals 0. So 65 cos alpha is equal to 25 over 65, which is equal to 5 over 13. So cos alpha is 5 over 13 when theta is a max here. So what we were asked to show. Theta has a maximum when cos alpha is equal to 5 over 13. And deduced that the time taken for the woman to cross by the shortest path is 13 seconds. Well, we can say that the shortest path is where theta is a maximum. And we have theta as a maximum down here. So the cos of theta is 5 over 13. What are we asked to show? The time taken is 13 seconds. So if cos alpha is 5 over 13, A over H sine alpha is 12 over 13. So that's my J direction. And if we take my J direction, what was my J direction? 5 sine alpha, was it? What was my 5 sine alpha was my J direction? That's the how we're going to get the time. So 5 sine alpha, 5 by 12 over 13, 60 over, not right, 5 sine alpha, 60 over 13. What does that work out to be? Doesn't work out evenly anyway, but that's the velocity in the J direction, So that's going to be my speed, 60 over 13. So if I divide my width of my river by my speed, I should hopefully get what they're looking for. What's the width of the river? Do we write it in? 60 divided by, put down here, 60 divided by 60 over 13 is equal to 13. And this is time, so seconds. And we were asked to reduce the time taken by the shortest path is in our one 13 seconds.